Hi everyone. Today we're going to study general term of geometric sequence. Let us recall that a geometric sequence has a sub 1 as the first term with r as the common ratio and listed as like this. The first term is written plainly as a sub 1. The second term is the product of this a sub 1 and the common ratio. The third term is the product of this second term times the common ratio. So we see here, this is a sub 1 times r squared. For the fourth term, this is a product of this third term times common ratio. So we have a sub 1 times r cubed. To generalize, the general term, or we say nth term, of a geometric sequence is this. A sub n equals a sub 1 times r raised to power n minus 1. In this formula, we need the first term and the common ratio. Take note that this n here in the power is the same with the subscript of a. Let us have example 1. Find the general term of the following sequences. We have problems A and B. Let's begin with problem A. We have the first term 3, second term is 6, third term is 12, fourth term is 24. The general term formula is written here. We know that this formula requires the first term and the common ratio. We can simply get the first term in here, that is 3, and the common ratio, we will take the ratio of any two consecutive terms, like this 6 divided by 3, we will get 2. Or we can take another pair, this 12 divided by 6 is also 2. Or we can take this 24 divided by 12 is also 2. So the common ratio is 2. Substituting now these values to our formula, we have a sub n equals the a sub 1 is now 3 times the r, or the common ratio, now becomes 2 raised to the power n minus 1. So this is now our answer, and we will copy this below this problem A. Let us proceed with problem B. The first term is 2, second term is negative 4, third term is 8, fourth term is negative 16. Let us collect the first term, that is 2, and the common ratio is negative 2. Just to check, if we take this negative 4 divided by 2, that is negative 2. Or this 8 divided by negative 4 is negative 2. Or this negative 16 divided by 8 is negative 2. We can see here that the signs of our terms in here are alternating from positive to negative to positive to negative. That is what happened when our r, or the common ratio, is a negative number. Now, let us substitute these values to our general term formula. So we have a sub n equals, the first term is now 2 times our r is negative 2, that is raised to a power n minus 1. This is now our answer, and we will copy this below this problem B. This is now our final answers. Let's have example 2. Given a geometric sequence with a sub 1 equals 3 and a sub 4 equals 24, find a sub 2. We have our formula here, and we know to find a sub 2, we need to have the a sub 1, which is already here, but we don't have the common ratio. That's why we need to solve for r. Using the given, the a sub 4 equals 24, let us first write this a sub 4 with regard to our general term formula. It means the a sub 4 equals a sub 1 times the ratio raised to 4 minus 1. We will substitute this a sub 4 value as 24 and this a sub 1 as 3 respectively as given in our problem here. And for the r, that is raised to 4 minus 1 is 3. Let us divide this equation by 3 so that only r cubed on the right side remains. So this 24 divided by 3 gives 8, and this 3 r cubed divided by 3, only r cubed remains. So we can write r cubed equals 8. We want to get the value of r. Let us take cube root of both sides. So the answer for r is equal to 2. This is the common ratio. Now we are ready to get a sub 2, and this is equal to a sub 1 times r raised to 2 minus 1. And the power is simplified into 1. Let us now substitute the first term and the value of r that was derived here. So we have a sub 1 is 3 as given here, times the r is now 2 raised to power 1. So simplifying further, our a sub 2 is equal to 6. So this is our final answer. Let us have example 3. List the first 5 terms of a geometric sequence with a sub 6 equals 25 and a sub 8 equals 625. Here we have the 5 terms of a geometric sequence in general form. We have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Also, our general term formula is written here. A sub n equals a sub 1 times r raised to n minus 1. In this formula, we need the first term and the common ratio r. But these values are not given in the problem. So let us derive the first term and the r based on the given a sub 6 equals 25 and a sub 8 equals 625. Let us begin with a sub 6. Let us write this a sub 6 with respect to the general term formula. So we have a sub 6 equals a sub 1 times r raised to 6 minus 1. So 6 minus 1 is 5. And then let us substitute this value a sub 6 as 25. So we have now 25 equals a sub 1 times r raised to 5. Let us regard this as our equation 1. The next, our a sub 8. Let us write a sub 8 with regard to our general term formula. So we have a sub 8 equals a sub 1 times r raised to 8 minus 1. And this 8 minus 1 is simply 7. Let us now substitute this value 625 to our a sub 8. So we have now 625 equals a sub 1 times r raised to 7. And this is now regarded as equation 2. Our next step is to divide equation 2 by equation 1. So the left side will be 625 over 25 equals, the right side is a sub 1 times r raised to 7 all over a sub 1 times r raised to 5. Let us simplify both sides of the equation. This 625 divided by 25 will give 25. On the right side, we can cancel a sub 1 that is common in the numerator and in the denominator. And for the r, we will subtract the exponents as a rule of division of exponents with the same base. So this is 7 minus 5. So we have here r squared. And then find r. Let us take square root of both sides. So square root of 25 is 5. The square root of r squared is simply r. Or we can write r equals 5. So we have now this common ratio, which is 5. Let us substitute r equals 5 to equation 1 to get a sub 1, the first term. So we have this equation 1 is now written as 25 equals a sub 1 times r, which is now 5, raised to 5. Simplifying further, this 5 raised to 5 gives 3,125. Now let us solve for a sub 1. Let us divide this equation by the coefficient of a sub 1. That is 3,125. So this 25, if we divide by 3,125, it will form a fraction. While on the right side, if we divide this by 3,125, this coefficient will cancel. So we have a sub 1 equals the 25 over 3,125. If we reduce this to lowest term, meaning let us divide both numerator and denominator by 25. So we will get this 1 over 125. This value now is our a sub 1, the first term. So we can substitute this a sub 1 in here, in our first 5 terms of the geometric sequence. Now let us solve for a sub 2. Using our general term formula, we have a sub 2 equals a sub 1 times r raised to 2 minus 1. Let us substitute our values. The r and the a sub 1 are here. So we have now this a sub 1 is 1 over 125 times r is 5. We can cancel this 5 and 125 and we will have this 1 over 25. This is our a sub 2, the second term. We can substitute now this value in here. Next, let us find a sub 3. Using our general term formula, we have a sub 3 equals a sub 1 times r raised to 3 minus 1 or 2. And then let us substitute our values. The a sub 1, again that is the first term, is 1 over 125 times the r, which is 5, raised to 2. Simplifying further, this 5 square gives 25, and we can cancel this 25 with 125. So we will have 1 over 5. This is now our a sub 3. Let us substitute this value in here. Next, let us find a sub 4. Using our general term formula, the a sub 4 equals a sub 1 times r raised to 4 minus 1. And this 4 minus 1 is simply 3. Then, let us substitute the a sub 1, or the first term, and the common ratio. We have now 1 over 125 times 5 cubed. Simplifying this value, we have 125, which we can cancel with the denominator here. So the final answer, the a sub 4, equals 1. This value we will substitute in here. And the last term is a sub 5. Using our general term formula, this is equal to a sub 5 equals a sub 1 times r raised to 5 minus 1, which is equal to 4. Substituting our a sub 1 as 1 over 125, the common ratio of 5 is here, raised to 4. Simplifying this 5 raised to 4 is 625. Then we can cancel this 625 and the 125 here. That will give us 5. And this 5 we will substitute in here. So we are now complete with our first 5 terms of the required geometric sequence. This is our final answer. I hope you learned something from this video. See you again next time.